Yeah. So you have to find that point in the curve at which dy dx is 0, isn't it? The slope of the curve is 0. That is what you have to find out.
Yeah,
Perfect.
yeah,
Hmm.
yeah,
Okay.
yeah.
Okay. So you try doing dy dx at all the points, and the point at which the slope is equal to 0. That means this is the slope of this point, right? That is your that is the theta 0 for which the cost function is least. Is it clear?
Hmm.
Is it clear? It's very important point actually.
Yeah. Clear.
Rupesh, is it clear? The point, see, this is the curve here. What you have to do, you have to find that point in the curve. I mean, don't worry, you have to don't do it by code or something. It will, that's our application will do. It will find that point in the curve at which dy dx is equal to 0.
Yeah, understood. Yeah, yeah.
Understood, right? So that is the final objective. Okay, so if you see here, you have to minimize j theta 1. That means the cost function you have to minimize by changing value of theta. That is what this line means.
Hmm.
Okay, by changing the value of the theta 1, you have to find this cost function. So that this is typically, or so this is your, you remember I spoke about so this is the prediction. H theta is your prediction, isn't it? This one,
Yeah.
Yeah.
this is your prediction. So xi means for ith data, this is the prediction. Okay, this is the actual value. Got it, right?
Yeah.
Okay, so this is the difference between the actual value and this, you are squaring it up.
Yes. Yeah.
Okay, then what are you doing for what you're doing here?
Summation.
Yeah, summation. What you're doing here, you're adding those, all those elements. Okay,
Okay.
what you're doing here, the summation, you're adding those elements, and your 1 by 2m is equivalent to, okay, finding a square root of this. 1 by 2m is done so that mathematically it remains the same. Okay, don't go, I mean, I can explain those why it is 1 by 2m, but needn't bother now. So understood, right? So this is the cost function. You have to minimize this cost function by changing theta 0 and theta 1. Understood?
Yeah.
Yeah.
Okay, so that is what, this is the goal, minimizing theta 0 and theta 1 so that this value is minimal here. Fine.
Mhm.
Okay.
Okay. Okay, so that is what we have to do. We have to find best value of theta 0 and theta 1 here. Okay, so that was a 2D graph what we saw earlier, right? Now what we have understood, right? Till now, what is that you have to find out theta 0 theta 1. Okay, now what you do here,
Hmm.
this is your theta 0, this is your theta 1, this is your theta 0, this is your theta 1. Okay, this is your theta 0, this is your theta 1, and what this is j theta 0, j theta 1. Okay, so for theta 0 theta 1, this is the cost, and you're plotting it here. This is a contour graph.
Okay.
Okay, 3D graph, because you have two variables, one cost function. So this might be, this will be the cost function, this will be the cost function. So for a theta, for theta 0 minus 10 and theta 1 to minus 10, this is the cost function here. This is the cost here. Understood, right? Okay, so what you have to do, you have to, from this 3D graph, right, you have to find the point where this is least. So what you do, you do d by dx at each point and typically try to find the point at which this is least. Clear, right?
Hmm.
Okay, so
Hmm.
this process of finding out the point at which the cost function is least is known as gradient descent, this mechanism.
Sorry, can you repeat the line?
Yeah. So what you have to do, you have to find out the point here at which the cost function is least. Okay.
Okay.
Okay. I mean, using gradient descent, we find the point in the curve at which the cost function is least. Got it, right?
Okay. That we will be doing by whatever earlier you told, the derivative slope,
Hmm.
those things.
Yeah. So gradient descent, is a mechanism. So that's a formula. I mean, I'll explain what is gradient descent. Okay, but using gradient descent for a particular, this is j theta theta zero, j theta theta one, and this is theta zero theta one. You typically use gradient descent to find the point in the curve at which the cost function is least.
Okay.
Okay, so the formula is very, I mean, the logic is very simple. What do you do? Imagine yourself at top of the hill. Okay, imagine yourself at top of the hill, and you have to find, what you have to do. You have to find out the bottomest point in the hill in this region, isn't it?
Mm-hmm.
Okay, bottomest point. To find the bottomest point, okay, what do? You at wherever you are, right? Just imagine that it is foggy next to you. You can't see it very deep. You just can't see the next step. What you'll do? You'll try to go to the area which is little deeper, isn't it?
Hmm.
Okay,
Yes.
from here you'll try to go to the area which is little, from here you'll try to go to the area which is little, from here you'll try to go to area which is little deeper, and so on.
Mm-hmm.
Okay, so this process is known as gradient descent. So we'll do using directly APIs, all this stuff, so don't need to bother much, but understood, right? So what is the value of, so remember, theta 0 theta 1 is nothing but in slope and intercept. So which is the best slope and intercept for this particular stuff data set is one at which the slope is least. Understood? What is the math behind it?
Okay, so for gradient descent, we will get once we are want to get the minimal cost function. So gradient descent is a single value for that minimal value,
No, gradient descent
or
is the
there will be like
mechanism using
multiple.
which,
Okay, okay,
okay, gradient descent is the mechanism using which you find the point in the curve at which cost is least. Understood, right?
okay, okay,
Gradient descent is a mechanism. It's a
okay,
function.
okay.
Okay. Okay. So that is what gradient. So what is gradient descent? Suppose you have a curve, right? Using gradient descent, you will be trying to find out. See, using gradient descent, this is the cost function. Okay, curve for cost function. Using gradient descent, what you'll do, you'll try to find the point in the curve at which the cost is least.
Mm-hmm.
Understood, right?
Yeah.
Okay, so I'll stop the mathematical part here. In the advanced courses I'll go more deeper. Okay, but you got a hang of what is happening around, right, in linear regression?
Yeah.
Yes.
Yeah.
Fine. Okay.
Yeah. Fine.
Okay. So understood so far what is supervised, supervised machine learning, what is linear regression, little bit theoretically. Okay. Let's now use whatever theoretically we have learned. Let's try to use it practically and see what is happening here. So this is the inbuilt data set. Okay, you can see we are loading SNS. This is Seaborn SNS. This is the library for visualization and data. SNS load data set. What you're doing here, you have iris data set. Okay, you are loading this. Okay, well, this is your iris data set. Let it load. So it is loading this stuff. That means iris is a very popular data set. I will be using a lot in the sessions. Iris is typically your petal. Iris is a flower type. Okay, so this is your sepal of a flower. Sepal mean flower size. I mean, there are two type of things in the flower. One is petal, one is sepal. Okay,
Mm-hmm.
petal is the smaller petal is the smaller figs of the flower. Sepal is the larger figs of the flower. Okay, so what you have two things. One is sepal length, sepal width, petal length, petal width. Okay, so this is 1980 data of some botanical institute, and what they store this information, as well as they try to mention the species. The species is Setosa. So there are three possible species: Setosa, virginica, and one more is there. Okay, understood the data set. So you have 4 columns here and one class of data here. Is it clear?
Yeah.
Okay, so let me load it. So if I do iris dot okay, so you can see first cloud type is Setosa, next is virginica, and the middle one was something like Setosa virginica. Forgetting it. Do it. So these are Setosa virginica, versicolor. There are 3 types: Setosa, virginica, and versicolor. Okay. Okay, virginica and versicolor, 3 types. Okay, understood, right? This is a very useful data set. What is the size, shape of the data? This is 4 columns. So how many features are there in the data?
How many?
Features.
Four.
Yeah, 4 features. 1, 2, 3, 4. How many? What is the label information?
Label information does what?
Yeah, label information is a species here. It is Setosa, virginica. This is the classification
So
data,
three.
right? 3 possible labels: the Setosa, virginica, and versicolor. 3 possible options. And this is species is your label information. That is a target. So what type of problem can be used to solve this classification problem, isn't it?
Yes. Yeah.
Right? Because your out data is pretty much fixed. Okay.
Yeah.
Okay, so try loading this stuff. So what is the if you do shape, you will find you have 150 rows. That means total 150 sample data is there, and you have 5 columns here. 4 is your feature, 1 is your label. Fine. Okay, just this I'll use this very soon again. Okay, yeah, so remember this data set. Huh? So what I'm doing now, I'm actually trying to create some data. So this is numpy. Now what I'm doing, I'm creating a random number generator function, but I have initialized that with seed 11, so that every time it will generate same sequence of numbers. So this is my x is my 10 into 50 numbers, whatever I have generated so far, right?
Yeah.
Okay, so x is my 50 numbers, 50 one dimensional array of 50 numbers. Fine.
Where you have mentioned seed.
This is the seed 11.
Okay, but earlier we used to mention like np.random.seed here.
That is one way. This is another way.
Okay.
Okay, this is another way. So this is what you were mentioning, seed. And if I try to if I try to print x, it is like this. It's all random number, just that I have multiplied 10. Generally random number is between 0 to 0 to 1, and now we're multiplying 10. That's why you're getting like this. Understood, right?
Okay. Yeah.
Okay. And if I do x shape, what is the shape that will print? It will print you 10 50 comma, right? Because it is one dimensional data only. Fine. Okay, but what we want this one. Remember I was talking about new axis.
Yeah.
Okay.
Last class.
Right. Hey, new x np new x is what will this do? This will add one dimension to the data. That means if I do x and colon np new x is then shape, it will convert my it will this data will return my data with 50 rows with one column. This is adding one dimension here.
Okay.
Yeah.
Okay, this is adding one dimension here and dot shape. Okay, that's why it is adding. So forget about this now. Okay, let me show the few things. I'll do this later. So what is your y is equal to 2 times of x plus 1.5, isn't it? So y becomes like this. Fine. Okay, so you have x and we have y, just two random numbers, but y is related to x. Just for a moment forget that I have told, I have, you have seen this for a moment. Okay, so what will I do is I will try to train my machine learning model with this is my target variable y and this is my training variable x, whatever is it. Fine. Okay, I will just give my I'll just give my machine learning algorithm, I mean linear regression, this data as my x data and this data as my y data. Okay.
Yeah.
And what will it do is it will predict the relationship between the function. It will predict this function for you. Okay, that is what our machine learning algorithm is supposed to do, right?
Yes.
Okay, let's see. So this is how we'll do scikit-learn dot linear model. Okay, there is no rocket science to remember this. You have to remember this. So as sklearn linear model means all the linear regression related stuff will be present inside this package. Got it, right? Okay, sklearn linear model import linear regression. Now what you're doing here, you are creating this model. Just for a moment, don't no need to really bother about what is fit intercept. Just create this is if you go to the, if you remember the diagram that I was showing, this is that empty training. This is this stage, right? Learning empty algorithm, right? This is learn empty. Okay, so this means it is empty. It has no, it is not trained. This is like creating a brain, new brain. So what is the first thing that you have to do? You have to train it. Okay, for training it you need to pass the y information, that means the output information, and you need to pass x information also. But remember, you should pass a list of data. Each data should be a list. Understood? Okay, each data should be a list. That's the reason we are converting it to np new x's. That means each data should be a list. If you see x looks like this now when you have passed it here like this. Is it clear? Because this is your training data and each corresponding value of y is there. So what you're doing now, you're training the model.
Yeah.
Right?
Yeah.
Is it clear?
Yeah.
Yeah.
Okay, so you have this data. So you're training the model. After you have trained the model, a magical thing we'll see now. If you write model is equal to coefficient, it is 2. What is coefficient? Coefficient is your slope, right? It wasn't this our equation of the data?
Yes.
2 into 2 was the slope here, isn't it?
Yeah.
So we didn't tell our machine learning model that this is the slope that we used. Okay, we just gave it input data, output data. It found out the slope and it found out the intercept for you. Pretty much close to actual numbers, isn't it? Did you guys understand till this point?
Yeah.
If you understood this point, this is this is the heart of machine learning. From data you are deriving the function, isn't it? And all you're doing here is just telling what type of function do you want. Fine.
So
okay.
once we are deriving the model, then after that we can ask the particular model anything. For example, coefficient, it is giving the coefficient. If we tell the intercept, it will give the intercept.
Exactly. Okay, and once you have, like I'll show you, once you have created the model, right? Once you have created the model and it is doing all these things for you, you can use it. Okay, you can use it model.predict. Okay, just pass any data to it. Okay, it will return you the corresponding. Suppose this is your y, right? First data is this, right? This is my x. Suppose I pass any x, it will predict y for you. This is my x, you have to pass it like this. Okay, suppose you want to actually pass it like this. Okay, see, this is your 5.1053. Is this my y? 5.105, this is my y, isn't it?
Yes, yes.
Is it clear, guys?
Yeah.
It is clear.
Okay, it's interesting, isn't it?
Yeah, yeah.
Okay, nice. Okay, so go through these stuffs today, try to execute this stuff. Okay, whatever you have heard today, right, the documents is there in the GitHub, same place. You'll find with the same name. Okay, whatever, PDFs and all are also there. Go through them. If not, you can find the PDF, and you can, if you don't want to go through, you can use this guy also. They, follow this guy. There also these things are explained: linear regression, linear algebra you study, linear regression you study. Okay, so go through them. Okay, this is like heart of machine learning. If you've understood, there is nothing in machine learning that you will not understand, because this is like core concept.
Okay.
Okay, uh, so how is the learning so far? Are you guys fine with the learning?
Yeah, yeah.
Yes.
Okay, in that case, can you do a small favor? In that case, because this month we are driving this. Okay, can you, if whatever positive and negative feedback you have, right, you can, provide us a feedback here. Got it, right? Just search for Zekelabs and provide your feedback here, right? Write a review will come. Is that okay?
Yeah, yeah.
Okay, so that helps us, keeping things on track. Okay, so fine so far. Any doubts?
Yeah. No.
Understood.
I will be checking the thing. The first part recording I have done. The second part, this can you send us?
Right. I'll stop recording. Okay, and
Yes.